So hello and welcome everyone. Welcome to Kreatryx channel. So first of all, let me introduce myself. My name is Vishal Soni and I have cleared engineering services examination 2 times from electronics and telecommunication branch, both times in double digit rank. In 2014 my rank was 98 and in 2015 my rank was 25th. I have served as a Group A Gastro Officer in Indian Railways and in Indian Telecommunication Services. So most of you must have been following me on the Kreatryx channel for electromagnetic field theory. So if you are a seeker of a free education, this is the channel for you, and you must understand that all these free initiatives is coming your way because of the Unacademy. So Unacademy is the revolution in the field of the free education and the affordable education. So how can you access those free courses? So if you want to access the free courses, you must immediately subscribe this channel, Kreatryx channel, because all the top educators of the country is providing the free course on this channel. And that free course is absolutely brilliant in content, that is systematic, that is organized, and that is complete. So complete playlist you will be getting of a particular subject. You can develop the concept, you can gain confidence. More than that, you can love the subject. So immediately subscribe this channel. Secondly, if you want to access more free content, then you must immediately download the Unacademy Learners app, because on the Unacademy Learners app, top educators of the country are conducting the free special classes. In that free special classes, you can get topic wise clarity of a particular concept. And do not forget to follow me on the Unacademy learning app, so you can also access the courses. So you must have two things. First is your YouTube channel. This YouTube channel, Kreatryx YouTube channel, must be subscribed. Secondly, you must understand that you should have the Unacademy learning app. That is must for you in order to crack the examination. So these are the parts of the free education. And if you want to organize your content well, if you want more comprehensive manner, if you want other advantages of the Unacademy, then what are the other initiatives that is running by the Unacademy? So another initiative that is running by the Unacademy is Unacademy Plus. So on the Unacademy Plus, this is very affordable for those who actually want to take their preparation to the next level. So आपको Unacademy Plus में क्या क्या मिलेगा? You will be getting the live classes on a fixed time, so that you can get more disciplined, you can get more organized, and you have something in your mind that at this particular time my classes are going to run. Apart from that, you will get free test series designed by the educator itself. So gone those times when we have lot of errors in the test series, we do not have the discussions of the test series. So there the test series will be conducted by the educators. They themselves will be discussing the solutions of that particular thing. So you can imagine that your preparation is going to the next level for this. Apart from that, those who have prepared themselves for the examination, so for them there are crash courses also available. Again the crash courses will going to help you in achieve good ranks. Those who have already achieved good ranks and want to improve their rank, for them there are rank improvement batches. More than that, you can also see that there are unlimited practice sessions. So what do you understand by unlimited practice session? Which means there will be various doubt solving sessions. Apart from the doubt solving sessions, there are weekly quizzes, and with the help of those weekly quizzes you can enhance your problem solving skills. So lot of unlimited doubt solving sessions, lot of quiz sessions, systematic content, structured content. You can download the PDF after the lectures, so you don't have to waste your time in order to making notes. You can utilize those times to practice the particular concepts, or you can use those times to just write down the formulas so that you can remember those formulas quickly. Apart from this plus subscription, there is also one subscription which is known as Iconic. So Iconic subscriptions are for them who actually do not have the self motivation but having the talent. So if they are having the talent and you do not have the self motivation, that how can I push myself to crack the examination, so in this Iconic subscription you will be assigned a personal coach. So this personal coach is going to be with you every time, and he will help you to achieve your dreams. You will get a study planner which will be customized for you. You will get the expert guidelines who have already topped the examination. They will be basically hand holding you to crack the examination. So if you think you are not self motivated, if you think you do not have the proper background to crack any particular competitive examination, so this Iconic subscription is must for you. This is going to help you. So if you want the free education, then YouTube channel and the special classes are must for you. And if you can afford a little bit, how much you should afford, that we'll discuss in a while. But if you can afford a little bit, you should come on to this Unacademy Plus. And more than that, if you want the expedited process in your preparation, आप जल्दी से एग्जाम निकालना चाहते हैं, जल्दी से अपनी गलतियां सुधारना चाहते हैं, so this Iconic subscription is for you. Then now let us start today's lecture, which is on the communication system. So friends, till now we have discussed two types of modulators. One is square law demodulator. This square law demodulator is not used practically.
Similarly, another demodulator that we studied was envelope detector, and envelope detector can be used only when mu is less than or equal to 1. So obviously there is a need of another demodulator which can be used for all values of mu, whether mu is less than 1 or mu equal to 1 or mu greater than 1. So such type of demodulator is known as synchronous detector. So synchronous detector is generally used when mu is greater than 1. So let us understand what is a synchronous detector. So the circuit of synchronous detector is very simple. A synchronous detector is having a multiplier followed by a low pass filter. So let me draw this block diagram of synchronous detector. So before actually drawing the synchronous detector, I am drawing a prototype of AM modulator at transmitter. So at the transmitter, the message signal is given to an AM modulator. Here also we apply a carrier signal which is AC cos omega ct plus 0 degree. The frequency of the carrier signal is omega c and the phase is 0 degree. This is known as carrier signal at transmitter. So the output of this AM modulator will be a AM signal and it is transmitted by this transmitting antenna. So at the receiver, there will be a receiving antenna which will receive this AM signal which is propagating through free space. So AM signal will reach here. First block of synchronous detector is a multiplier and here also we will generate a carrier signal, but this carrier signal is known as locally generated carrier signal. So this carrier signal will not be exactly same as the carrier signal at transmitter. It will have some frequency error and some phase error, and it is known as locally generated carrier at receiver. Now the next block of synchronous detector is a low pass filter. The transfer characteristics of the low pass filter will be something like this: H of omega versus omega, passband gain is 1 and cutoff frequency is similar to the cutoff frequencies of message signal minus omega m and omega m. So the input of low pass filter I am assuming xt and output of low pass filter I am assuming as y of t. Now let us understand, if the transmitter is present in India and this receiver is present in USA. So the user in India will generate the carrier signal with frequency omega c and phase 0 degree. So it will ask the user which is present in USA to generate the same carrier frequency, but two carrier frequencies from the local oscillators cannot have same frequencies. There will be slightly some difference. So the user at USA will generate a carrier signal which has frequency exactly not equal to omega c, but the frequency omega c plus delta omega, and this delta omega is known as frequency error. Similarly, the here is phase is 0 degree and the locally generated carrier will have phase delta phi, so it will not be equal to 0 degree, but it will have some phase error which is known as delta phi. So here delta omega is known as frequency error between transmitted carrier and locally generated carrier at the receiver. Delta phi is known as phase error between transmitted carrier and locally generated carrier at the receiver. And here I'm assuming delta omega and delta phi both to be constant or not as a function of time. So now let us do the mathematical analysis. Here SAMT will be AC plus MT cos omega CT. The locally generated carrier at the receiver is AC dash cos omega CT plus delta omega T plus delta phi. So the output of X of T will be SAMT into CL of T. So it becomes AC plus MT cos omega CT AC dash cos omega CT plus delta omega T plus delta phi. So X of T becomes AC dash into AC plus MT cos omega CT plus delta omega T plus delta phi. Okay. Now I will multiply it by 2 and divide it by 2. So that I can use the formula of 2 cos A cos B. So it becomes AC dash by 2 AC plus MT. And we will apply 2 cos A cos B here. So it will become cos A plus B or cos 2 omega CT plus delta omega T plus delta phi plus cos A minus B will become cos delta omega T plus delta phi. Now, what will be the output of low pass filter? So low pass filter will pass frequencies up to omega m and it will suppress the frequencies which are centered at omega c or above omega c. So this will have two impulses at 2 omega c. So it will not be allowed by the low pass filter. So the output of the low pass filter YT will become AC dash into AC by 2 plus AC dash MT by 2 into cos of delta omega T plus delta phi. So I will multiply it. So it will become AC into AC dash by 2 cos delta omega T plus delta phi plus AC dash MT by 2 cos delta omega T plus delta phi. So finally the output can be written as AC dash by 2 MT cos delta omega T plus delta phi plus AC into AC dash by 2 cos delta omega T plus delta phi. So now I am considering case 1. In case 1 I am assuming that the frequency error is not equal to 0 while phase error is 0, or we can say that the locally generated carrier is not synchronized in frequency but it is synchronized in phase. So what will be the value of YT? So YT will become AC dash by 2 into MT cos of delta omega T plus AC into AC dash by 2 cos of delta omega T. This portion does not have any message signal information, so this can be termed as interference. This is having information of message signal, but it is multiplied by a time varying signal. So we can say that it will never generate a message signal, rather it will always give us a distorted message signal. So whenever frequency error is present in transmitted carrier and locally generated carrier at the receiver, the message signal can never be recovered, or we can say that whenever the carrier at the receiver is not perfectly synchronized in frequency, in that case the message signal can never be recovered. In case 2, I am considering that delta omega is 0 and delta phi is not equal to 0. So in this case, yt becomes AC dash by 2 mt cos delta phi plus AC into AC dash by 2 cos delta phi. Now since delta phi is constant, so this complete term behaves as a DC, and if we pass it through a capacitor, so it will block the DC, and output will be mt multiplied by AC dash by 2 cos delta phi. This is also a DC term, so we will pass it through an amplifier and output can be obtained as mt. So in this case the message signal can be recovered. So whenever frequency error is 0 and phase error is non-zero, in that case also we are able to recover our message signal. Now let us discuss the case 3. In case 3, I am talking about the perfect synchronization. Perfect synchronization means the transmitted carrier and the locally generated carrier are perfectly synchronized in both phase and frequency, which means both delta phi and delta omega is 0. In that case, y of t will become AC dash by 2 mt plus AC into AC dash by 2. Here also this will behave as a DC term, so if I will pass it through a capacitor, it will block the DC and output will be AC dash by 2 mt, and if I will pass this through a amplifier, in that case we will get message signal. So whenever the locally generated carrier is perfectly synchronized in both phase and frequency, then also the message signal can be recovered. Now, till now we have understood that when the locally generated carrier is perfectly synchronized in frequency, then the message signal can be recovered whether phase synchronization is present or not. So now let us discuss the case 4. In case 4, I am assuming the frequency error as 0 and phase error as constant, but this constant value is odd multiples of pi by 2. So for this particular case, I am assuming delta phi as pi by 2. So what will happen in this case? The output will become AC dash by 2 mt cos pi by 2 plus AC into AC dash by 2 cos pi by 2, and the output will be 0. So whenever frequency error is 0 but phase error is constant, and that too the odd multiples of pi by 2, in that case also message signal cannot be recovered, or we can say that the output will not have any term present or nothing will be observed at the output. So what are the situations in which the message signal can be recovered? So by using synchronous detector, the message signal m of t can be recovered only when delta omega is 0 and delta phi is constant, and this constant value should not be equal to odd multiples of pi by 2. So now we have seen that whenever phase error between transmitted carrier and locally generated carrier at the receiver is odd multiples of pi by 2, in all that cases yt becomes 0, and this condition is known as quadrature null effect, which means when the phase is at quadrature between transmitted carrier and locally generated carrier at the receiver, in all that cases output will be observed as null or no output will be observed. Now initially we have assumed that delta omega and delta phi must be constant. So the circuitry which is used to make this delta phi is constant is very costly, which makes synchronous detector a costly receiver. So the synchronous detector is very costly circuit, while envelope detector is very cost effective or cheap circuit. So for mu less than or equal to 1, we will always use envelope detector, and for mu greater than 1 we will use synchronous detector. And this synchronous detector is very costly, while envelope detector is very cheap. Now next important topic is power requirements in AM. So let us understand this topic. Suppose we have message signal m of t, and which is having spectrum band limited to omega m. So this will be omega m, this is minus omega m, this is m omega, and this will be m of 0. Now the general expression of amplitude modulated signal is AC plus MT cos omega CT. So I can write it as AC cos omega CT plus MT cos omega CT. Now the Fourier transform will be pi AC del of omega minus omega C plus del of omega plus omega C. So this is the Fourier transform of this term, plus m of omega plus omega C by 2 plus m of omega minus omega C by 2. This is the Fourier transform of the second term. Now if I draw the spectrum of this signal, this is SAM omega versus omega. So in the spectrum, we will observe two carrier components at omega C and at minus omega C. So this term in time domain is responsible for carrier frequency terms in frequency domain. Now this second term has Fourier transform something like this, which means the spectrum is shifted to minus omega C leftwards and omega C rightwards. So we will have this spectrum. This is omega C plus omega m, omega C minus omega m, this is minus omega C plus omega m, and this is minus omega C minus omega m. This area is pi AC, this is also pi AC, and the peak value will be m of 0 by 2. Now let us understand. This first term is responsible for the impulses at the carrier or for the carrier component. In DSB FC. Now what does this second term contribute? So if you remember, we said that the frequencies above omega C is known as upper sideband and frequencies below omega C are known as lower sideband. Similarly here also, this is upper sideband and this band is known as lower sideband. So the sidebands which we are getting in the modulated signal is due to this second term. So the second term is responsible for sidebands in spectrum. Now let us have a look on the information content. So the complete message information is stored in this triangle. This we can use as an analogy that this information of message signal is present in this triangle and no impulse is present in the spectrum of message signal. Similarly, if we see the sidebands, the sideband is also having triangular shape, or I can say that this sideband is having same information as that of message signals, or no impulse was present in message signal while impulses are present in modulated signal, but these impulses does not have any message signal information. So what we can say that from time domain also we can see that this term does not have any empty component, while this term has component of empty, and in spectrum also we can observe that complete information of message signal is stored in the sidebands, and carrier component does not have any message signal information. So what I can say that the amplitude modulated signal has three components. One is carrier and another one is sidebands. So carrier component does not have any message information, while the sideband contains complete information of message signal. So what is the purpose of this carrier signal? What is the purpose of carrier signal? So let us understand one by one. So in case 1, I am assuming that SAMT is AC plus MT cos omega CT, or I can write it as AT cos omega CT. So we know that this is our message signal M of T. This is AM, this is AC. Now, if this carrier component or AC is added in it, then we get AT. So the AT will be AC plus MT, and in that case we are assuming that AT is completely greater than 0. So we get the graph of AT, which is AC plus AM, somewhere here AC, and somewhere down here AC minus AM. So from here you can observe if AC is added in MT, then only AT becomes greater than 0, and we know that whenever AT is greater than 0, the envelope will always be equal to AT. And by using envelope detector, we can generate ET, which will be A of T or AC plus MT, and by using a capacitor I can recover my message signal. And we already know that envelope detector is very cheap circuit or very cost effective circuit. So whenever this AC term is present here, it is making the envelope or this AT term greater than 0. That is why the envelope will always be equal to AT, and the recovery of message signal is very easy, or it can be done by using a very cheap circuit known as envelope detector. Now let us discuss the second case. This was the expression for AC plus MT cos omega CT. So I can write it as AC cos omega CT plus MT cos omega CT. So now we know that the complete information of message is stored in this term. It does not contain any message information. So I am making this term as 0. So ST becomes MT cos omega CT. Now let us try to understand whether we can use envelope detector in this case or not. So this is our M of T. This is your AM minus AM. Now we know that in this case, if I will try to extract the envelope, since this A of t is nothing but M of t, and from here we can say that in all these regions our A of t is not always positive, so the envelope will be equal to magnitude of AT or mod of MT. So this will be the envelope. Now, can you say whether the message signal is stored in envelope or not? Clearly, we can see that the message signal has sinusoidal shape, while the envelope does not have any sinusoidal shape, but it is having the full wave rectified version of message signal. So in this case, if I will pass my modulated signal through an envelope detector, the output will be magnitude of AT or mod of MT, and it will not be equal to MT. So in this case, the message signal cannot be recovered by using envelope detector, which is a very cheap or cost effective circuit. So the purpose of carrier component or this carrier AC is to make the detection of a modulated signal very cost effective. So with carrier component, modulated signal can be demodulated by using envelope detector, while without carrier component, modulated signal cannot be demodulated by using envelope detector. So this is the basic purpose of carrier component. The carrier component allows the use of very cost effective demodulator, which is known as envelope detector, and if carrier component is not present, then at least envelope detector cannot be used to demodulate the signal or to recover the message signal. Now let us understand what are the power requirements of different components. So we know that total power in AM is PC into 1 plus mu square by 2, or I can write it as PAM is equal to PC plus PC mu square by 2. So this is the carrier power and this is the sideband power. So for mu equal to 0, we know that the PC will be PAM upon 1 plus mu square by 2. So for mu equal to 0, the carrier component requires complete AM power, and since mu is equal to 0, so sidebands will not be present and sidebands will require 0 power. For mu equal to 1, the carrier power will require 2 by 3rd of total AM power, or 66% of total AM power, and obviously the remaining power will be required by sidebands, which is 1 by 3 of total AM power, or we can say that around 33% of total AM power. So from here, try to understand. The carrier component does not carry any message information. Still, it requires 66% of total transmitted power. While the sideband components carry message information and it requires only 33% of total transmitted power. Which means this 66% of total transmitted power is being wasted because it is not carrying any message information. But why we are willing to spend this much of power? So let us try to understand that why we are willing to spend this 66% of total transmitted power. So let us have a setup in which we have a single transmitter and thousands of receivers. Now, this sort of communication is also known as point-to multi-point communication, or sometimes it is also known as broadcasting application. Broadcasting means we have single transmitter and thousands of receiver are receiving from the same transmitter. So in this setup, what we are saying, if 100-watt power is required for transmission, out of which 66 watt is taking for carrier component and around 33 watt is required for sidebands component, and our message signal information is present in sidebands. So we are wasting the 66 watt power here. But what luxury does it give? If the carrier component is present, then at each receiver we can use envelope detector for demodulation. So we are using envelope detector at each receiver, and if thousands and thousands of receivers are present, then each receiver will have a cost effective demodulator. So this is the simple case of the designing of a cost effective setup. So we are wasting 66 watt of power here, but a large amount of money we are saving by designing the cost effective demodulator. So the purpose of using this carrier component is to make this setup cost effective, or ultimately the optimization of cost. So what is the bottom line? The bottom line is that carrier component does not carry any message information. Still 66% of total transmitter power is given to it, because in some specific applications such as broadcasting, where a single transmitter is present and thousands of receivers are present, so in that case we will waste our 66 watt power, or we will invest some money in wasting this 66 watt power, but we will save all these monies by designing this cost effective demodulator. So we are wasting a little amount of money here, but we are saving a large amount of money by designing this cost effective demodulators. So the very basic purpose of AM modulation is broadcasting. AM modulation is only used for point to multi-point communication, because in AM modulation the carrier component is taking 66% of total power, and we are wasting some money for this 66 watt power, but we are saving a large amount of money by designing this envelope detector at each receiver, and envelope detector is very cost effective circuit. So whenever there is a usage of point to point communication, in case of point to point communication, which means we have only single transmitter and single receiver, we will never use AM, because in AM a large amount of carrier power is wasted here. So what we will do, we will invest some money in designing a costly receiver and we will save the transmitter power. So it basically depends upon the optimization of cost. But whenever point to multi-point communication is being used or broadcasting application is used, we will always prefer AM because AM will give us the luxury of designing a cost-effective demodulators. So now let us understand few standard datas for AM. So AM has few standard datas. In AM, each message signal is band limited to 5 kilohertz. The bandwidth of AM signal, we know that 2 into maximum frequency component of message signal, or it becomes 10 kilohertz. The carrier frequencies which is used in in AM is from 535 kilohertz to 1640 kilohertz. So these are the carrier frequencies on which the message signal is translated. And last one is intermediate frequency. So the intermediate frequency here is 455 kilohertz. So the AM modulation occurs below 2 gigahertz. 2 megahertz. So the complete AM modulation occurs below 2 megahertz. We have different modes of propagation. First one is ground wave propagation. Ground wave propagation occurs below 2 megahertz or up to 2 megahertz. In ground wave propagation, suppose a transmitter is present here and the receiver is present here. Even if transmitter is not able to see the receiver or both are not in line of sight, then also the data is transmitted from transmitter to receiver by propagating the wave along the ground or by multiple reflections along the ground. This information is transmitted from transmitter to receiver. So this type of propagation occurs only if the wave which is propagating has frequency less than 2 megahertz. So from here we can see that in case of amplitude modulation, where the carrier frequency is below 2 megahertz, the ground wave propagation takes place and due to ground wave propagation, AM can travel a long distance, hence sometimes it is also known as long distance propagating wave. So AM is used for long distance communication. Second mode of propagation is ionospheric wave propagation or sky wave propagation. It occurs between frequency range 2 megahertz to 30 megahertz. Next one is space wave propagation or line of sight propagation. This occurs frequencies above 30 megahertz. In line of sight propagation, both transmitter and receiver should be in line of sight. So if a transmitter and receiver is present here, then they are not in line of sight. So In line of sight communication, a long distance communication cannot be possible because when the transmitter and receiver are present in line of sight, then this communication is possible. But if transmitter and receiver are not present in line of sight, so they will be hidden under the curvature of the earth. So this type of propagation is used for short distance communication. So whenever the carrier frequencies are above 30 megahertz, in all that case, space wave or line of sight propagation takes place, and line of sight propagation does not travel a long distance, because when transmitter and receiver are present at long distance, they will always be hidden by the curvature of the earth, or their propagation will always be limited by the curvature of the earth. So in all that cases, only short distance communication is possible. So in case of FM, which is having carrier frequency from 88 megahertz to 108 megahertz, in that case only line of sight propagation takes place. So the line of sight propagation cannot be used for long distance communication, because when transmitter and receivers are present at long distance, their line of sight is restricted by, or their propagation is restricted by, curvature of the earth. So whenever line of sight communication is taking place, it will always travel very short distance, or the transmitter and receiver must be present in line of sight. So in case of AM, ground wave propagation takes place, and in case of FM, line of sight communication takes place. So obviously the AM is used for long distance communication, while FM is not used for long distance communication. Now what are the advantages of AM? So first advantage is, for mu less than or equal to 1, a cost effective demodulator is present, which is envelope detector. Second important point is, due to ground wave propagation, it can be used for long distance communication. So these are the two major advantages of AM. What are the disadvantages of AM? First of all, it is limited to transmission of voice frequencies only. Next is, it requires high transmitter power. But the reason we know that high transmitter power enables the use of a cost-effective demodulator. So as long as the purpose is broadcasting, this high transmitter power does not count as the disadvantage. Now, comparatively, high transmission bandwidth is required. It is affected by quadrature null effect. So these are the few basic disadvantages. Now, lastly, what are the applications? So we know that AM is used in broadcasting applications or from point to multi-point communication. Thank you.
So if you have liked today's lecture and you want to subscribe the Unacademy Plus, the very first thing that you should understand that you should use this particular code. What is the code? The code is VishalGate. Write my name and attach GATE to it. So by using this particular code, you will be getting all the advantages of the Unacademy Plus. All the added advantages will be directly assigned to you. Secondly, you will directly come to under my guidance, and that will surely help you to crack the examination in the least possible time, and you will also get the guidance of the complete team. Okay, and the most important thing is that you will immediately get the 10% discount on that. So immediately you are enabled to get 10% discount once you use this coupon code. So for example, if you talk about the plus subscription, which is costing you 25,000 for 1 year, and if you use this coupon code Vishalgate, immediately you are going to get 10% discount, which is 22,500. And if you talk about the iconic, for the iconic subscription of the 12 month, this will cost you around 40,400. So these are the cost of the 12 months. And if you want to talk about the 2-year subscription cost of the plus, it is your 27,000 after discount. If you want more discount than 10%, and you have already attended the special classes, then you will be having some credits in your account. Do not forget to use those credits so that you can get more discount than 10%. Now, how can you pay these amounts? So there is one good news for you, that you can pay this amount by using credit cards and debit cards by using the facility of the zero cost EMI. So if you want to pay this particular amount of 22,500 with the help of zero cost EMI, so the zero cost EMI can be availed by using credit cards and debit cards. Remember, you can use the credit card of any company, but the debit card is allowed for HDFC and the Bajaj Finserv. Apart from that, if you want to directly pay this much of amount, you think that this particular amount is the most affordable fees that can be provided to you for 1 year subscription, तो आप directly क्या कर सकते हैं? You can use this credit card, debit card, direct payment. You can also go for the EMI options, okay, and you can directly pay this amount by using net banking. Every time you think of the Unacademy Plus subscription, the first thing that should come in your mind is this particular code. Do not forget to use this code once you take the subscription, because I have already told you that this particular coupon code is going to give you the lot of advantages, so you cannot miss the opportunity to use this code. So every student who want to come on to the Unacademy Plus, they want to take the advantages of the Unacademy Plus, they want to empower themselves in the best possible manner in this digital era, they want to be the part of this revolution, then this is the time for you. You do not have to wait for it. If you are in the first year, if you are in the second year, you are in the third year, the best possible time is right now to prepare for the examination, to dedicate yourself, to give yourself the opportunity so that you can get the success as early as possible. Apart from that, you should also join this GATE aspirant group. So this GATE aspirants group is already having 150k plus students, so you can join it. There are a lot of discussions going on between students. You can get the advantage of those discussions. Okay, you can also join this Kreatryx channel, which is a Telegram channel. So everyone has to join this channel so that you can get all the PDFs of the lecture which is being assigned to you. Fine. There are various channels which you can go for it. So various channels in the association with Kreatryx, so you can follow the channel of your interest. And this is it in today's lecture. So let us meet in the next lecture. Thank you so much.